between Germany and Denmark. We need to change the name. All right. It's a collaboration project, Interreg 5A project, and it's in priority 1, which is innovation. So what is the motivation for do such a project? So there is a wide need for preventing infectious diseases, as witnessed by the COVID pandemic previously, a couple of years ago. And one way of preventing infectious diseases is by doing proper hand sanitization. But the problem is that not everyone sanitizes their hands, but probably they should. And we aimed at designing a robot that will help improve this sanitization rate. So that will nudge people, convince people, motivate people to use hand sanitizers more, and thus improve disease prevention through enhanced hand disinfection. So a little bit about Interreg. It's one of the key instruments of the European for supporting regional development. So it's a regional project funding, and it includes areas in northern Germany and southern Denmark. So this is the so-called project region that I'm sure you already know about this. And its aim is to jointly tackle common challenges and find shared solutions in fields such as health, environment, research, education, transport, and so forth. So regarding the HanDiRob budget, so the total budget of the project is around 671,000 euros. Out of that, 403,000 euros was financing by Interreg, and the rest was co-financing by the project partners. And the duration was from the 1st of April 2021. It was supposed to end at the 30th of September of this year, but we got an extension of 3 months, so it's actually ending at the end of the year, so in a couple of weeks. And as mentioned, it's part of Interreg Priority 1, which is innovation, which aims at increasing product, process, and social innovation within the identified program area. And we have a website that you can access there. So regarding the partnership, of course, for Interreg projects, it's very important that we have representation from both sides of the border, the collaboration between partners from Denmark and Germany. And I think we have a good balance of this. So the lead partner is our university here, SDU, and more specifically, we at SDU Robotics. So we are experienced in designing mobile robots, robot behaviors, human-robot interaction, and we were in charge also of testing that robot that we built. Then the project partners were Universität zu Lübeck, Universitätsklinikum Schleswig-Holstein, so the combination of the two entities, and represented by Robert here, and they were in charge of designing the disinfection stand, which they did a great job at, and they also did testing of the robot, and especially of the quality of the disinfection that was used. And we have Fachhochschule Kiel, represented by Franziska, and they are experts in user interface design, so they helped us with that, explore different solutions for designing the user interface, and they were in charge of public relations. We also had network partners in Odense University Hospital, who were very kind, represented by Søren and Esben, who were very kind to offer us their facilities to test the robot, which was very, very helpful in the project. And we have a company, Abena, who was in an advisory role in the project to advise us on the commercial aspects. Yep, so we have very much complementary competences between the project partners, and I think it worked quite well in the design process. So we are experts in robotics here at SDU, and UZL, they are experts at mechatronics and testing medical devices, and Fachhochschule Kiel in public relations and user interface development and testing. So it is very important to have this balance between different partners and competences. Yep, so we had a number of work packages, as you can see here. Project management, public relations, the development of the robot and the stand, and the testing of these. Some concrete goals were to create a fleet of hand sanitizers, 1 mobile unit and more hand disinfection stands. A robot and stand work also separately. So as you can see here, demonstrated right here, we have the mobile base and the stand, and they can work separately and also together. And the robot can lift the disinfection stand. Can we have a demo of that? And it can carry it to either some people who want to use it, or for logistic purposes. So it can bring it somewhere to be refilled, or the battery to be recharged. Right. All right. And now it should be able to drive around. And we can turn around the stand itself. So the stand has an additional degree of freedom right there. So yeah, it has multiple purposes, as we said. So to recharge the battery, to bring in, to refill the disinfection, to interact with people, and to redistribute stands. Yeah, as mentioned, the tasks were divided between the project partners. And regarding the project results, just quickly at the beginning. So we developed actually 3 robot platforms. One is with the shell, and some of them are without shells, but fully functional. And we have 3 robot stands. So the original was built by Robert's team in Lübeck, and based on these blueprints, we recreated one here in SDU, and then Franziska also built one at Fachhochschule Kiel. So that's really cool. During the testing, we interacted with more than 2,000 people. So we promised 100, so we consider this a success. So at least 2,000 people have seen our robot being used at the facilities. So either at Odense University Hospital, or at UKSH, or at the mall where Franziska did testing. So we had 2 hospitals, 1 mall, and 1 university as testing grounds. And yeah, we published 3 scientific papers, and 1 already in the press, and we plan to write an additional one. And we contributed by more than 50 social media posts. And we had strong scientific results, which showed the usefulness of speech and motion for hand disinfection. So basically, what we have found in this project, scientifically speaking, what was the very important part is that such a device, which is interactive, which can speak, which can move, which can address people, is leading to much higher levels of compliance. So much more people sanitize their hands when they are being approached by a robot or being talked to by a robot than using a regular hand sanitizer. So I will focus on these results in a little bit. But basically, so this was the idea. On the left side, you see what we started out with before the project itself, and we ended up with this. It's a little bit different, but on the other hand, quite similar. And I have to thank my team here for building this robot, this part, and then Robert's team for building the stand part of it. But yeah, so from concept to implementation, so we achieved this, and testing. We achieved this during the project. I'll talk more about our results later. So now I would ask Robert to present his part of the public presentation.
Can you use your computer? Yep. So you don't have to switch over?
That's great.
Just have a USB stick with viruses and a presentation.
Jump the gun there. It's PowerPoint or?
Yes, it's PowerPoint. And yeah, it's in the HanDiRob folder. Summary. Okay. Yeah, also a warm welcome from my side. My name is Robert Wendland, and I'm presenting the summary of the results that we achieved here in Lübeck on behalf of the University of Lübeck and the University Medical Center Schleswig-Holstein. My team there, or our team, consisted out of Jörg Schröter and Torben Dorband, and the last one has already left our institution, so he's not here to present his work by himself. He actually was the key person to design and build the hand sanitization robot that you see here in full working capabilities. What did we work on during the project? We mainly focused on the development. That means we developed, designed and built the hand disinfection stand, and also we delivered blueprints and components for the project partners in Kiel and in Odense to build their own, which are also functional right now. And we finished our work with testing of the robot components that were developed, and also we had a study on the quality of hand disinfection using the hand sanitization stand. Some of the main goals for the design of the hand disinfection stand. It's important to have a user-centric design of the disinfection stand. It has to be accessible for different groups of users, smaller one, bigger one. For instance, also persons in a wheelchair might also be able to access the hand sanitizer. So we optimized the placement of the different sensors, the actuators, the display and other UI components so that they are easily accessible, and also on the other hand that the possible users are available and visible for the sensors within the robot. Obviously there needs to be a power supply for the disinfection stand in order to drive the different components, the display and also the sanitizer, the dispenser by itself. We designed it primarily to be of lightweight design to save resources. So it's 3D printed right now in a very specific form that on the inside it's completely hollow, and it's not designed to be a shell and hollow on the inside, but we have a structure that organized by biology. It's rather similar to how our bones do look like from the inside. So we have a spongy-like design that fills the inside of the design with sparse struts of polymer, and on the outside we have a more or less compact shell, and this is similar to how our bones are being designed, and this is very easy to produce on 3D printers. And thus the device itself is rather lightweight. We end up having lots of weight due to the battery that we are using. So the heaviest components are in the foot, which you cannot see right now. But this is intended to give the device more stability, so it's very hard to tip it over when the center of gravity is extremely low. Also, we designed and testing the coupling procedure with the base system that you just saw in action during Oscar's presentation. And also as a bonus, we developed a mask recognition, which as you see right now is not really that important anymore. But during the high times of the pandemic, where everybody was required to wear a mask, we considered having an algorithm that's able to see if the persons walking past the robot are wearing a mask. Might be actually a good, I'm feeling stalked by the robot. Such an algorithm we consider to be a good idea to maybe give a small nudge to remember to wear the mask correctly. So what's inside? Here you can see the different components. We have, I can also show it here for instance. Obviously we have a screen where a user interface is being shown, and also in some software versions there is an instruction on how to disinfect your hands. We have microphones on top, we have a camera on top, we have speakers, Most important, obviously, is the dispenser for the fluid. And then we have some more components that are very hard to see on the outside. For instance, we have these LED lights, which can show the full colors of the rainbow, maybe indicating different phases of the interaction with the robot, which we haven't yet fully exploited, I have to admit. There are some sensors on the inside to detect the position of the robot by itself and also the position relative to the mobile base, so that the robot on top actually does see where it's facing. There are motors which enable the rotation, for instance, and what's now hidden here but shown here on screen, there's a specific docking area which connects to the mobile base. Obviously, we did lots and lots of testing during the development of the robot to get it into this shape, to have it working and fully functional. So different aspects have been tested, the components by themselves, the coupling procedure, the different aspects of the user interaction, and we used the results of the testing to improve the robot a lot during the design phase. Finally, we did a compliance testing together with Oscar and his team at the University Medical Center Schleswig-Holstein at the campus of Lübeck. So in the main entrance area, we tested the user interaction with the robot, and this turned out to be a very successful test. It also, some of the results did actually surprise me, but I think in a very good manner. It was more successful to really nudge persons to sanitize their hand than I would have expected, especially the modes where the robot is moving and where we might have some speech. Also, a little bit more specifically, we on our robot, we have an instruction showing how to sanitize your hands. So there's a step-by-step guide, which areas of your hands you have to touch and wet with the disinfection fluid in order to get them as clean as possible. And one of our goals was to test the specific part of the robot interface. If showing such a video on screen while having the hand sanitization robot is helpful in order to get the users to have a cleaner hand afterwards. So we designed a small study with a total of 47 subjects, which were recruited amongst the employees and the students at the campus of Lübeck. Some had a medical background, so they had continuous training on hand sanitization. But we told nobody what's the aim of the study, I have to admit. We told them it's going to be a study testing the effectiveness of artificial intelligence algorithms in detecting the outline of the hand. Otherwise, the study would easily have been biased when the subjects know the purpose of the study. Then we asked the subject into a room, and before the study should start, we asked them to sanitize their hand. Randomized one half of the group used a regular commercial hand sanitizer, and the other half of the group used the robotic hand sanitization stand with the video instruction shown on screen. And we added a fluorescent agent to the disinfection liquid. And what you can see here on screen is the hands, and you can see a brightish blue, light blue shine on the areas where the hands have been wetted thoroughly with the disinfection fluid and the added agent. And more or less we used the computer software to discern the parts of the skin which have been wetted and which have not been wetted, and found the ratio of the wetted area and the total area of the hand, and used this as an indicator for the quality of the hand disinfection. Unfortunately, it seems that our blinding approach to the subjects worked very well, and they wanted to move on quickly to start the study from their perspective and didn't really consider what was happening on screen. So what you can see in the results is that there's hardly any difference between the results. The total wetted area of the hands is 98% when using the HanDiRob, so the robotic hand sanitization stand. And for the plain regular hand sanitizer, it was roughly 1% point less than that. So it seems that this one-time approach of showing a video on screen to improve the quality of the hand sanitization doesn't turn out to be that successful. What's important to note, our design is not worse than a regular hand sanitizer, but I think using it more often and taking time to really look at the video might improve the quality of the hand sanitization in the long run. Yeah, these have been the most important points I wanted to share with you today. Is there a possibility to have questions?
Maybe after we finish them.
Okay, then thank you very much for your attention.
Now Franziska Stern. Thank you, Robert. Can you join the Zoom meeting?
Okay, I don't have a link.
How do you do this? Can I send you the link? And
You must allow me. You must allow me to host, to share my screen. I will. Just a second. Just think about which one. And the wrong one. Should I zoom on it? Yeah, okay. Hi guys. So that's my part to tell what the small work package of FH Kiel has been in this nice project. And this was basically producing some material for communication because I've heard that we have some communication guys among our students. So that's exactly what's being done right here, right now as well. And we had the pleasure of producing some flyers, some roll-ups, the websites to keep you all up to date about what's going on in the project. Also thinking about some search engine optimization to make sure that maybe also Google now and then finds what's happening here. To produce some press releases and share them in the local media. To produce some social media posts, which our nice student who can't be here today, Jihan, did. Then before her, it was Jan Hendrik, so we have quite a fluctuation of students having worked in this project. Jihan also did some interviews to make sure that the public can understand what you experts are doing in your offices before these wonderful machines come out here. A booklet is being produced, which is due next week. It's going into print right now. And we had some live stream of the first meeting of the kickoff. You might remember a long time ago now. And the other one is happening right now. Now it would be really nice if it would switch. Then some other students did some UI studies. And during this process, we found out that it works quite well when you're developing a machine. You're sitting close to it and your hands on your code. That is probably quite good that meanwhile you produce your own interface, which we can see right here on the machines. But anyway, it was our idea to have this shared because the project wants a cooperation of all of us. And some of our master students spend the time trying to find out what could this interface of a not yet existing robot be. And we knew that it should contain eyes. And they started with a tablet because there are no electrical engineers or other engineers, but some of them are designers, some are more into different subject areas. So they decided to produce this in a tablet and stick it into boxes and bring it into public and have some user stories experimented with and see for how long can you present a certain dialogue. Could you use spoken language? Could you use written language? If so, which language would work in a bigger area? And of course, you cannot work with written language if you have an international audience. So, as Oscar said in the beginning, work with eyes would be a good idea, what they finally also understood. But then it was also interesting to find out for how long should you show them, how quickly should they glimpse, what does it feel when they follow you with their eyes? And we found out, testing it in a local mall, that some people felt a little bit intimidated, younger ones felt rather attracted and wanted to be close to this meant-to-be robot, which now then has been assembled. And what people like very much is don't have a too long dialogue and make some happy emotional reaction when people have complied. So what they called a happy dance, like some really smiling eyes, was accepted very well by the audience. This is a learning that we now take into our courses, teaching further classes to get maybe on a new level, because this appears to be the future, having not only screens and smartphones talking to us, but also hardware devices. And now we've learned a little bit about what might they do and what not. And another thing we found out, okay, we need a robot of our own so we can work better on the interface. What we can see here is our students just trying to understand the hardware design for the 3D printing, and so they transferred all the knowledge from Denmark, from Lübeck, to reassemble a stand, getting the components together, and get the application running and test it, and also put in some animations. Unfortunately not with CSS as we all wanted, but they insisted on doing them in Blender, which is a bit slow for the Jetson, I think. And also you can have different approaches aesthetic-wise, but then there was a bit of freedom of choice how to do it. What I can finally say is that there's a lot of transfer from this network, especially for me, from Denmark and from Lübeck to us, because now we have the device, as you can see on the picture, that's now being used in teaching with us, and we can think about further phases, interactions, and what might come out of it, and maybe also from further projects. Thank you very much.
Okay, thank you, Robert and Franziska, for showing us your parts of the results. And now I'm going to focus on what we have done here at SDU in collaboration with our partners. So we started with a first version, second and third version of the robot, obviously. So the first implementation was rather simplistic, but it led us to the next ones. All right. So this was the initial idea. So to design this new type of robot, this U-shaped frame of the robot, which would be able to encompass a stand, a hand sanitization stand. So, we used some servo motors for moving the robot. So this was a proof of concept initial idea. So this is what we call version 1. And we further improved, I think, this version. It came a little bit longer. But we soon moved on to the next version, which is this one, which is the underlying part of this robot right here. So here we added some much more significant, much stronger servos. The OpenCR controller, we started with an NVIDIA Xavier processing unit, 2 linear motors for lifting the payload, an H-bridge for driving the motors, and quite a significant battery for operation. I mean significant, depending on relatively significant battery. Yep, and then Rasmus designed the shell of the robot, as well as the hardware of it, of course. So it took this current shape in this version 2. And this is the workhorse that we have used in all our testing. And it has been tested a lot, many hours. So, and it stood up the test of time. So it almost led to some short circuits today, but luckily everything is working. And it has been quite reliable. So, and here you have the stand as well. And yeah, basically we followed Robert's and Torben's blueprints to produce the stand. And we made some improvements or changes to the stand on our end as well. We added the barcode and so forth. And then we have version 3 of the robot, which we haven't finished yet. But let's take a look at the video. So one problem with version 2 is that basically it's quite slow. And so some people run away from us, so we can't catch them because the robot is just too slow to go after them. But let's see what happens with version 3. All right, so they are going head to head. So yeah, it's much faster. So I think no patient is going to be able to run away from us after this. Actually, we don't want to go after them, but so we test in testing. While we tried to approach them, they left the area, so that was a problem. Yeah. So what basically here is version 3. I don't know if you guys want to just maybe put it out here. Yeah. So we used different motors and more powerful, much bigger battery. Yeah, basically it looks quite the same, the frame and the rest of it as that one, but all parts of it were improved. So it's there's a larger battery, more processing power, much faster motors, and so forth. And we hope that it's going to work after this as well. But we still need to finish the shell. So the shell is printing, but hasn't been printed by the time of this meeting. All right, and then testing, which was the very important part of the project this year. And yeah, so we did testing at UKSH in Lübeck just a couple of weeks ago. And that went quite well, as Robert mentioned. And we also did a lot of testing at Odense University Hospital with Esben and Søren, so that went well as well. We also published a number of papers, 3 so far, and a couple of them in the making. And actually next week, some of us are going to Italy to the Conference of International Social Robotics, International Conference of Social Robotics, to present some of our results, some of the HanDiRob results, to further disseminate the results of the project. So what we have found here, so what the very important scientific findings are that an interactive hand sanitizer will lead to better hand disinfection compliance than passive solutions. Movement results in higher compliance compared to speech in noisy environments. So in these graphs, what you see here is we compare the compliance rate of the regular hand sanitizer to different versions of HanDiRob. So by compliance, we mean how many people sanitize their hand out of all people who pass the hand sanitizer robot, right? So 5 people use it, 10 pass by, then that's a 33% rate of compliance, right? So we have seen here that after the end of COVID, these compliance rates have sharply dropped, right? So people don't feel that compelled to use the hand sanitizers anymore because there's no maybe public pressure. So in our testing, in a particular, it depends on the location, depends on the situation. So these are not super general numbers, but they are comparable because these tests have been done at the same place. Right, so at this particular location, after hours of observations, the regular hand sanitizer achieved a compliance rate of around 12%. And our fully functional system with speech and movement achieved a rate of 50%. So that's quite of an improvement. And then we had the stand without the robot itself, just looking around. That achieved a compliance rate of around 18%. And then we had the robot speaking only. That achieved around 32% of compliance rate. And when the robot was only moving and not speaking, that was around 38%. So you see that as we introduce more interactive methods, the compliance rate increases. And yeah, so it was quite interesting to see. So the movement is quite important. So the movement is not that we are running after someone, but as someone is walking into the hospital, we approach them. So it's more like a gesture, right? So it's not threatening, it's not invading anyone's space, it just makes a presence, right? So if I'm entering the hospital, if you will, so if I'm entering the hospital, then the robot would make some slight movement to drive towards me and then turn the stand towards me. And this kind of behavior convinced people to use the hand sanitizer much more often. And we also did some testing, similar testing here at the university. And here you see the compliance rates are much lower. But it depends on the environment, right? So here we had the constrained entrance, and that leads to much higher compliance, right? If you have a hand sanitizer and people have to go through 2 meter space, then we have higher compliance. where there is a space for people to fan out, that's going to lead to much less compliance, as it was the case at the university. And here we see that the movement cases were much more significant than even the speech case. So, but it was a noisy environment. Basically, what we learned from here is that when it's a noisy environment, then speech doesn't work that well to motivate people. Then the movement is much more important. So we have observed this at the university, but also at UKSH. I think that as if it's a large area, it's a large space, then the movement takes over from speech in significance of compliance, if that makes sense. Okay, so then to just summarize the significant outcomes of this project is, so we further convince people, I would say, to about the importance of hand sanitization in the program region. So we reconfirmed, convinced people that it's still important to sanitize hands at hospitals especially. And we developed an even stronger relationship between the project partners, I would say. And that will hopefully culminate in the next project, which is in the phase of an application. So we are working on the HospiBot. So not HanDiRob, but this time HospiBot, which is going to be a generalization of this concept that we developed during HanDiRob. And we are working closely with UKSH, with Robert and Franziska, FHK, and also with OHU, so as project partners. And we have a number of other project partners on the project, so we have 8 or 9. So it's a larger project. And here we are going to focus on different functions that the robot can exert, for example, greeting, guiding, smaller logistic tasks, and so forth. And so these use cases were developed by talking to our colleagues at hospitals and learning from them what they actually need. And as talking to Søren, so they actually need robots of a smaller footprint, right? So which won't take up too much space. And HanDiRob is a perfect example of that. So, and it's also modular as well. So we think that there's a lot of possibilities for future development of a modular system that will serve multiple purposes at hospitals. So we are applying for next Interreg project, and the application deadline is in January. And so we hope that it's going to continue in that direction. Yep, and then we have Rasmus, who had a startup idea based on working on this project. So he did a lot of the hardware development. So what you see here is a lot of the design is his work. And so he's going to try to create a startup that will create robots for hospitals. You know, a little bit different topic, right? So maybe moving hospital beds or something similar. But basically he and one of his friends are going through this startup helping or innovation hub, how should I call it, at SDU, where they are going to try to commercialize this idea, which I suppose came out of HanDiRob. And yeah, as Franziska mentioned, so HanDiRob has become a popular teaching tool here at SDU. So I use it in my courses, and a lot of the students choose this platform as the platform of choice for conducting their projects. And later on, you will see some of the students' results, actually, what they achieved, and which are quite interesting. So the HanDiRob will live on in this shape as well. So as a teaching tool, same as at FHK. And we still plan to conduct research in the future with this platform. And we have been also approached by the children's department of OHU, which also who also saw a lot of potential in this platform for greeting purposes. So a little bit different purposes, but they liked the robot a lot, the interactive capabilities and so forth. So we'll be working on other research ideas as well. Great, so that would be the end of my presentation and the end of the presentations for this public part of the meeting. At this point, I would like to ask if there are maybe any questions regarding the presentation. So we are streaming online, and maybe, so there's a comment section. So if anyone would have from the public viewers from YouTube, the YouTube stream, any questions, please, you can post them as comments on the stream. And then maybe Rasmus will take a look at it if anyone posts something. Right, in the meanwhile, we can take some questions from here as well. Are there any questions from here? Connie?
I have one question. Oh, is it still on? Yeah, okay. I think my question might be for Robert, because you mentioned that you did some guiding on how to sanitize the hands. But maybe I didn't get, did you test that? And do the users, do they have the time to see the video? Because I think Oscar worked with that previously, and they didn't have the time, they just wanted to sanitize their hands. Did you test it?
Microphone.
I have one. Well, we took an educational video showing the different steps that are necessary to do an optimum hand sanitization. The time that the video takes to be shown on screen was the time that you usually need to take to sanitize your hand correctly. And it also was a situation where only one possible user was in the room. But it seems the users that we invited into our study have been distracted by getting to start the real study from their perspective. We just asked them to sanitize their hand after they signed a form. And we wanted to take, at least we told the subjects that we're going to take a baseline photo, just showing the hands without any mean. And then they've been asked to use another fluid which also contained this fluorescent agent and have this analyzed under the inside of a black box with an ultraviolet radiation or ultraviolet light, black light just. So from their perspective, it was just one hurdle that they had to overcome, getting their hands clean, so to not spoil the inside of the box or something like this. And they wanted to pass this as quickly as possible. So at least what we've been watching, they didn't really take time to sanitize the hand. So unfortunately, but it was both for both of the conditions, the regular sanitizer and the robotic one. Nobody really took care about what they are doing, sanitizing their hand. They just hushed through it and wanted to get over with it.
Leon just said that comments are turned off at YouTube.
Oh. Can you comment it? Can you try to comment it? Yeah, if I can just add to that, yeah. So in the previous project, as Connie said, we have found that people just don't have the patience, especially in the real world, to stop for a video. And I think it might have been similar here as well. But Robert wanted to, I mean, he did this controlled study. And, you know, it's hard to not tell them too much, but tell them enough, but not tell them too much, right? If you tell them, like, oh, you should watch the video, then you affect the results, right? So you don't want to affect them in that sense, and then they pay attention to the video. So it's a very thin line, if at all. But basically, people just want to be done with the hand sanitization, you know, and unfortunately, they don't care about being educated too much about videos. That's I think, my experience. Is that correct, Robert?
I agree.
Yep. But either way, I mean, we are still able to increase the compliance quite significantly, even without that. Comments?
We can comment.
You can?
There are no questions.
All right. All right. So one last time. So if anyone is following on YouTube, the public session. You can use the chat on the right side to post some questions to us here. And we'll just wait a minute or two to see if we receive any questions from the public. Yeah, I see there's delayed. So please feel free to ask any questions you might want online. Oh, and meanwhile, Daniel.
Do you want to talk about some of the automatic behavior that we also developed, or is that just for later?
I think that's better for later. Okay, so we'll do that in the private session. Right, great. Well, if there's no questions from the public, then I would like to conclude this part of the meeting, the public part of the meeting, and thank everyone for participating and watching online. So I hope it was informative. And yeah, after this, we'll continue with the closed part of the meeting. So thank you very much.